It is hard to believe this is a dam that America built over 90 years ago. Initially, to save construction materials, engineers chose the Colorado River next to the Black Canyon mountain range. Because the gap here is very narrow, they only needed to use half the materials to build a dam. However, what he did not expect was that the flow of the Colorado River is very strong. This caused the newly built dam to bend and the concrete inside to crack. Therefore, the engineer decided to change the dam to an arch shape and fill the interior with steel reinforcement. As powerful water pressure continuously impacted the arch dam, it gradually deformed. Although the concrete did not crack, the arch dam had a low center of gravity and lacked stability. When the load reached its limit, it would cause the arch dam to collapse. Therefore, the engineer increased the base area of the dam to overcome tensile stress and stability problems. Now, the dam will face another problem. The higher the dam is built, the greater its water storage capacity. This causes the pressure that the dam bears to continuously increase. Therefore, based on local rainfall, the engineer designed the dam height to be 726 feet, which is equivalent to 221 meters. After the dam design plan was decided, construction work began. The next thing to do was extremely difficult. Engineers needed to find a way to tame the fierce Colorado River before construction could proceed. However, draining the river water without affecting the flow was a difficult problem. The engineer thought for a long time and came up with a solution. He dug diversion tunnels on both sides of the river. Then he used sandbags to build a temporary cofferdam and pumped the water dry in the middle. This way, the flow could be diverted without affecting the river. The idea was great, but how to implement it? To facilitate digging the diversion tunnels, the engineer designed a special construction machine. He placed 2 rows of scaffolding behind the truck so that it could accommodate 30 people on top. These people used drill bits to drill holes in the rock and place explosives. After the explosives were installed, the truck pulled the scaffolding and workers quickly moved to a safe location to blast. Next, they used excavators to clear the debris and rubble. When the tunnel entrance was blasted open to prevent collapse, they needed to install a large amount of steel-reinforced concrete inside. Therefore, the engineer laid tracks on both sides of the tunnel. He used cranes to haul concrete and steel reinforcement to speed up construction. However, workers encountered difficulties when pouring concrete in the tunnel. Because the viscosity of the concrete was insufficient, it easily fell off the walls. Therefore, the engineer found an arched hydraulic form machine. This way, workers could easily complete the concrete pouring work at the top, as blasting, clearing, and pouring were repeated many times. Workers took 18 months to dig through the 4 diversion tunnels on both sides. Next, the engineer piled up the rock debris that trucks had previously cleared in the middle of the river to build a temporary cofferdam. This way, the river was successfully diverted. Now construction of the dam could begin. When the engineer was constructing according to the previous design plan, he discovered that the rock on both sides of the riverbed was very fragile. It could not support the dam at all. Therefore, he had workers drill holes in the rock walls and place explosives. He used blasting to clear the loose rock on the sidewalls. He also blasted openings in the mountains on both sides. At the same time, the dry riverbed could not bear the weight of the dam. The engineer had workers dig down 300 feet, which is equivalent to 91 meters. After reaching the hard bedrock, large-scale concrete pouring operations could begin. Initially, workers made forms from wood and then poured concrete into them. In order to transport concrete to the riverbed bottom more quickly, the engineer invented a dumping device. They just needed to use cranes to lower huge iron buckets containing concrete to the riverbed bottom. Then